This is our third day on velocity, and we're going to come back to example 3 analytic, and we're going to start with worksheet 3. So that's where we're going to go right now, worksheet 3, where it says speed is the absolute value of velocity. It tells you how fast something is moving without regard to the direction of movement. Question number 1 says, what effect does absolute value have on numbers? It will always be positive. Okay, if I take the absolute value of something, it will always be positive. All right. So that's the first important piece of information. The second one, what effect does taking the absolute value of a function have on its graph? Now, I see some of you showing me the V sign, and you are correct in that you're thinking, that that's the absolute value graph, but that's not the answer we're looking for. Here's what we're looking for. If I were to graph regular old f of x equals, let's say 3x minus 6. Okay, that is a linear that goes through negative 6. And it comes up, of course, just a regular linear like that. By the way, which x-coordinate does it hit at? 2. What is this right here? Well, couldn't I set 3x minus 6 equal to 0 and solve it? Right, so it would be 2. Yes, this is 2. Now, if I were to do the absolute value of this linear, if I were to do the absolute value of 3x minus 6, you just told me that if I take the absolute value of a number, it is always positive. So graphically, what happens is this part down here gets reflected up here. And so to answer question number 2, we would say, what effect does taking the absolute value of a function have on its graph? Well, it reflects the negative function values across the x-axis. Okay? So, and that is true for any function. What if I had a quadratic like f of x equals x squared minus 7. Well, what does that look like? Well, that's a quadratic moved down 7 units like that, right? If I were to do the absolute value of x squared minus 7, then this part down here would get reflected across the y-axis, and it would look like this. So it would look kind of funny. I mean, it would have this big hump in the middle. Your final graph would look something like this. It would come down, have a big hump, be like that. Because the part that was negative got reflected. Okay, and that's the effect that absolute value has, is it makes any negative value is going to become positive. All right? And if we think about that, that makes sense. What's f of 0 in the original function? Wouldn't it be negative 7 down here? Well, if I take the, if I take the absolute value of negative 7, it's positive 7. Okay, so that little low spot, the minimum of the quadratic, gets flipped up. Okay, so that's the situation there. Now, let's keep going. For each situation below, the graph of a differentiable function giving velocity as a function of time t is shown, along with selected values of the velocity function. In the graph, each horizontal grid mark represents 1 unit of time, Each vertical grid mark represents 4 units of velocity. For each situation, plot the speed graph on the same coordinate plane as the velocity graph and fill in the speed values in the table. Then answer the questions below based on both the graph and the table of values. Now, didn't it say the speed graph? Speed is the absolute value of velocity. Okay? Velocity has both a value and a direction. Speed is just a magnitude. Okay? Speed is the absolute value of velocity. All right? So, if we look at situation 1, we were told to plot, they give you the velocity graph. Well, aren't those all positive values? Right? So if I'm going to graph, if this is my velocity graph, then the speed graph is going to go right on top of it, because they're all positive. All right? So down below we have these statements. In this situation, the velocity is positive, right? I'm looking at the first statement down below the graph. The velocity is positive and what? Increasing. Okay, the velocity is positive and increasing. Now, because velocity is increasing, we know acceleration is positive. By examining the graph of speed and the table of values, we can conclude that speed is increasing. Yes, all the speed values are the same as the velocity values. But now we come to our next big point, and I mentioned this earlier in class. We just had this statement. By examining the graph of speed and the table of values, we can conclude that speed is increasing. Why? Because, and you need to add this somewhere, okay? Add this on the bottom of your page. If velocity, let's just say if velocity and acceleration have the same sign, and we're talking about positive or negative, then speed is increasing. Or we can just say speeding up. And that is whether they are both positive or whether they are both negative. If my velocity is positive and my acceleration is positive, then it is speeding up. If I'll draw a little line here, if my velocity is negative and my acceleration is negative, it is also speeding up. It just happens to be speeding up in the negative direction. Okay? So if the signs of velocity and acceleration are the same, the particle or the object is speeding up. That's statement number 1. And I think you know what statement number 2 is going to say. Statement number 2 says, if the signs of velocity and acceleration are opposite, then the particle is slowing down. So if your velocity is positive and your acceleration is negative, then we can conclude it's slowing down. Vice versa, if the velocity is negative and the acceleration is positive, the particle is slowing down. And we will stop there for today.